I have been exploring the causes of flooding around the world intensively for 5 years. I found out about the floods in South England from the media reports, and I decided to visit the location in person. When I reviewed the images of this area in Google Earth, I reached a conclusion that the main culprit of the flooding could be the compacted agricultural soil that the tractors leave behind as they work the fields. Compacted soil means soil pressed by a tractor wheel in which, under pressure, originate pores through which the water flows. On the first day, as I looked out of the car, traveling from London Airport to the area affected by the floods, I could see that my assumptions were valid. In Kingsbury Episcopi, I climbed a hill with a friend to get a good view of the flooded area. There was an orchard on the other side of the hill, with easy identifiable tire tracks among the trees. My experience has shown that compacted soil in the tracks does not soak in water, but rather drains it swiftly into the lowland with the eroded topsoil. The agricultural soil on the mounds nearby clearly showed compacted and eroded tire tracks, 2 times 65 centimeters wide tracks. Next, we went to the fields that were about 1.5 kilometers away, overlooking the flooded Mochelney. In a wheat field with compacted tractor tracks that were 40 centimeters wide, digging in with a spade was very hard. The soil, which was free of tractor tracks, on the other hand, was quite easy to dig. When we simulated a 20mm rainfall on half a square meter of compacted soil, the water ran off immediately and filled the hollow dug out under the examined area. The simulated 20mm rainfall soaked into the uncompacted soil within 4 minutes, where the pores would channel it into the groundwater. In this case, the dugout hollow under the examined area remained empty. Soil pores means channels in the soil that supply the plant roots, springs, and groundwater systems with water. The simulation in a cornfield yielded similar results. Here, the tire tracks were 70 centimeters wide, and the simulated 20mm rainfall soaked in the uncompacted soil in 6 minutes. The hollow under the compacted soil, the tire track, filled with water. Underneath the uncompacted soil, the hollow remained empty as the water soaked into the ground. In January, rainfall in the Somerset County totaled 220 millimeters. That equals 7.1 millimeters per day, or 0.3 millimeters per hour. The documentary has made it evident that the rainfall drained only on compacted soil, which is 20 to 23% of the cornfields, and even much higher after harvest. 5 to 7% of the wheat fields. 5 to 7% in other crop fields except meadows. If all the surfaces compacted by the tractor tires were restored by agitating the soil to loosen it, the rainwater could soak in immediately where it falls, and the consequence of protracted rains need not be so catastrophic. Rainwater behaves the same way on a compacted soil as it does on an asphalt road, yet the water that drains off the agricultural soil and the woods carries the fertile soil along with it as well. Over time, our fields and woods dry out and turn into areas filled with gravel and stone. What legacy shall we leave behind? Cities of concrete? Asphalt roads? Deserts? If we want our planet to survive, we need to preserve what is indispensable to life: water and arable soil where there is land. A solution to restoring soil by agitation, which loosens the earth which has been pressed in by a tractor wheel, exists.